Okay, morning, guys. Yesterday we started a unit three. Okay, so unit three is moment distribution method. Okay, so we saw the technical terms in unit three. Okay, so first of all, can you hear me? Still, Kritika?
Yes, sir.
Okay. So we saw the technical terms, fixed end moments, then carryover factor, stiffness, and distribution. Okay, there are four technical terms in the moment distribution method. Okay, you please recall that. What is fixed end moment? Okay, so what is meant by fixed end moment? Can anyone say? So what are all the Sivakritika, Vignesh? Yeah, can answer. Sivakritika,
Sir, moment at the fixed and supports the sir fixed in moment.
moment at the fixed end supports only fixed end moments. That only we are saying that as a fixed end moment. Okay, so what about stiffness? What is meant by stiffness or define stiffness? Yeah, you can answer. Sivakritika.
Sir, force required to produce unit displacement, sir.
Force required to produce unit displacement. Okay, then what will be the unit for stiffness?
Newton per meter, sir.
Newton per meter. So for stiffness is force by displacement. So unit for force is Newton, and unit for displacement is meter or mm or centimeter. So
அக்கா ஏங்க எல்லாம் வெளியே போயிட்டாங்க?
தெரியல மோகன் சார் பேசுறது எனக்கு கேட்கவே இல்ல.
ஆமா, வராங்க எல்லாரும்.
சார் தான் காணும்.
Yeah, can you hear me now?
Yes, sir.
So, okay, sorry, the network issues. Uh, so, Sivakratika, are you there? And other than Sivakratika,
Sir, மோகனும் அசோக்கும் இருக்காங்க சார்.
only 3 members are there.
Yes, sir.
Okay, no problem, no issues. We'll start the class. Okay, so I didn't present the screen. Okay, one of my name showing the board. Okay, just ping that screen. Okay, so in last class we start two terms, four terms. Okay, first one is fixed end movement. Okay, so the movement at the fixed end of the support is termed as the fixed end movement. Okay, then we saw stiffness. Okay, so stiffness is going to be small k. Small k. So stiffness is equal to force by displacement. Okay, force by displacement. So unit for stiffness is Newton per mm. Okay, then third term is carryover factor. Carryover. Okay, so carryover is nothing but we are transferring a movement to the far end. Okay, so now we are considering a support A. Okay, we are considering joint A. We are transferring a part of the movement to the far end, that is B. Okay, so that is carryover. Okay, so normally carryover factor, a part of movement means how much movement will the carryover means half of the movement. Okay, so what movement we are applying in that half of the movement will carry over to the near end. If the near end is fixed then only means we can carry over. Okay, so carry over means half of the movement of the movement will transfer to the near fixed end. Then fourth term is, whether you're seeing the board or not, I don't know. Sivakratika, you apply. Fourth term
Sir?
is, you can see this portion now, distribution.
Yes, sir. Yes, sir.
Okay. The fourth term is distribution. Okay. So distribution means for balancing purpose to make the beam to in equilibrium condition, we are making that distribution. Okay. Yeah, movement we are distributing. Okay. Some joint may have more more movement. Some joint may have less movement. So we are distributing the movement evenly. Okay. So evenly means how much amount of movement we have to distribute. Okay, so we have to calculate the distribution factor. Okay, then we have distributing the movement to the supports. Okay, so these are the four terms we learned in yesterday's class. Okay, so do you have any doubts in this? Guys,
Sir, distribution மட்டும் இன்னொரு தடவை சொல்லுங்க சார்.
distribution means you are distributing. Carryover now you are applying a movement. Okay, additionally you are applying a movement. Okay, so if you are additionally you are applying a movement means, okay, some amount of movement will transfer to the nearby end also, nearby support also. If the nearby support is fixed means some amount of will transfer. Okay, carryover பாத்தீங்கன்னா அடிஷனலா சப்போர்ட் அப்ளை பண்ற மூமெண்ட் பேலன்ஸுக்காக மூமெண்ட் அங்க இருக்காது. ஓகே, ஒரு அடிஷனலா மூமெண்ட் அப்ளை பண்ணாதான் பேலன்ஸ் ஆகும். ஓகே, ஸோ நீ அடிஷனலா அப்ளை பண்ற மூமெண்ட் வந்துட்டு அதான் கேரி ஓவர் மூமெண்ட். ஓகே, பேலன்சிங்காக அடிஷனலா நீ அப்ளை பண்ணுவ. ஓகே, ஸோ அதான் வந்து கேரி ஓவர் மூமெண்ட். ஸோ அந்த அப்ளை பண்ற மூமெண்ட் வந்து பாதி வந்துட்டு நியர்பை சப்போர்ட்டுக்கு போகும். நியர்பை சப்போர்ட் ஃபிக்ஸ்டு சப்போர்ட்னா தான் நியர்பை எண்டுக்கு பாதி மூமெண்ட் டிரான்ஸ்ஃபர் ஆகும். இல்ல நியர்பை சப்போர்ட் இன்ஜிட் சப்போர்ட்னா பாதி மூமெண்ட் அங்கே டிரான்ஸ்ஃபர் ஆகுது. ஓகே, இது வந்து கேரி ஓவர் மூமெண்ட். டிஸ்ட்ரிபியூஷன் அப்படிங்கிறது ஆல்ரெடி அங்க இருக்க மூமெண்ட் நீ டிஸ்ட்ரிபியூட் பண்ற. ஓகே, ஆல்ரெடி சப்போர்ட் ஜாயின்ஸ்ல மூமெண்ட் இருக்கும், அது வந்து அன்இவனா இருக்கும், ஈக்குவலிபிரியம் கண்டிஷன் இருக்காது. ஸோ டிஸ்ட்ரிபியூட்டிங் தட் மூமெண்ட்ஸ். ஓகே, ஸோ அதுதான் டிஃபரன்ஸ். டிஃபரன்ஸ் கேரி ஓவருக்கும் டிஸ்ட்ரிபியூஷனுக்கும் அதுதான். Distribution means the moment already in that joint Okay, you are distributing that moment for equilibrium condition. Carryover means a carryover moment means you are applying an additional moment for a equilibrium condition. Okay, புரிஞ்சுதா சிவகிருத்தியா?
Yes, sir.
Okay, now we'll see the problems. Wait for a while.
சார் உங்க வாய்ஸ் கேட்க மாட்டேங்குதுங்க சார்.
Sorry guys. So yesterday we saw fixed moments, stiffness or relative stiffness, distribution, carryover. Okay. So moment distribution method. In moment distribution method, so these steps will come. Okay. The first step may be calculation of fixed end moment, then relative stiffness calculation, then distribution. That is distribution factor we have to calculate. Okay. We are not distributing evenly. Evenly means not half of the moment will go this side, half of the moment will go this side, like that. Okay, so we are distributing evenly for balancing. Okay, so the evenly term is denoting for the equilibrium condition. Okay, we are distributing the moments evenly to make the structure to a balanced one or a stable one or an equilibrium condition. Okay, then carryover. Okay, so carryover means we are applying an additional moment. Okay, we are called that moment as a carryover moment. Okay, if we apply an additional moment means a part or not a part, half of the moment will carry over to the near end. Okay, if the near end is fixed. Okay, because a fixed end only will have moment. Okay, hinged end or roller support and all will not have moment. Okay, so you guys understand now. So yesterday we saw a simple problem. Okay, for just for calculation of fixed end moments. Okay, if the span as a UDL means, if the span as a UDL means the fixed end moment formula is WL square by 12. Okay, left to right is anti-clockwise, right to left is clockwise. So MFAB anti-clockwise, MFBA clockwise. Okay, if the span as eccentric point load means the formula is WAB square by L square, WA square B by L square. Okay, uh, left to here also the left to right anti-clockwise, right to left is clockwise. Okay, so this problem only we saw in yesterday's class. Okay, the minus WL square by 12. Okay, for a UDL load, and for a eccentric point load the formula is WAB square by L square. That is left to right, right to left. For positive side WA square B by L square. Okay, whether you guys noted this formula? Karthik?
Yes, sir.
Huh? Okay. 1 minute, Karthik. Okay, sorry guys. So we'll see a problem today. Okay, this problem we'll see this one. Okay, so the question is analyze the continuous beam shown in figure by the method of moment distribution. Okay, we are analyzing this continuous beam by using moment distribution method. Okay, so what is the result? Okay, what are the results or what is the final step of this analysis of these beams? Whether you're understanding what I'm asking. Finally, what we are calculating, that only I'm asking. Can anyone answer? Mohan Kumar? Mohan Kumar?
சார்
என்ன கடைசி என்ன கண்டுபிடிக்க போறோம்? அனலைஸ் பண்ணி ஒரு பீம் அனலைஸ் பண்றோம். ஸோ கடைசி இதுதான் நமக்கு ரிசல்ட்னு சொல்லி எப்படி நம்ம கண்டுபிடிக்கிறோம்? இந்த பீம் வந்து சேஃப் இல்ல, இது சேஃப் இல்ல, we have to redesign அப்படின்னு சொல்லி எப்படி கண்டுபிடிப்போம் நம்ம? The final step என்ன?
சார் கால்குலேட் மொமெண்ட்
Final moments of shear force. Okay, if a structure, if the moment is not within the limit, means the structure will collapse. Similarly, if the shear force also is more, it is also not in the limit, okay, then the structure will collapse. So the final output of the analysis of beam is bending moment and the shear force. Okay, so that only we are calculating final moments and shear force diagram and all. Okay, so the நமக்கு வந்து ஒரு இப்போ நீ எப்படி கம்ப்யூட்டர் ப்ரோக்ராம் அவுட்புட் பண்ண கோடிங்லாம் போட்டு ஃபைனல் அவுட்புட் ரன் பண்ணி பார்க்கும்போது உனக்கு ரிசல்ட் காட்டுது, அந்த மாதிரி நமக்கு வந்து ஃபைனல் ரிசல்ட்ங்கிறது வந்து பெண்டிங் மூமெண்ட் டு ஷியர் ஃபோர்ஸ் தான். ஓகே, ஸோ அது நம்ம டயக்ராம மென்ஷன் பண்ணா பெண்டிங் மூமெண்ட் டயக்ராம் அப்படிங்கிறோம், ஷியர் ஃபோர்ஸ் டயக்ராம் அப்படிங்கிறோம். ஓகே, ஸோ த அவுட்புட் ஆஃப் த அனாலிசிஸ் ஆஃப் த பீம் இஸ் பெண்டிங் மூமெண்ட் டயக்ராம் அண்ட் ஷியர் ஃபோர்ஸ் டயக்ராம். ஓகே, ஸோ இது ஒரு சிம்பிள் பீம் தான். ஓகே, டூ ஸ்பேன் கண்டினியூஸ் பீம் ஏபி அண்ட் பிசி. ஓகே, இன் ஸ்பேன் ஏபி we are having a UDL load, and in span BC we are having a eccentric point load 40 kilonewton. Okay, so there are different methods. Okay, you can solve this analyze this beam by using slope deflection method, uh, conjugate beam method, Macaulay's method, double integration method, different methods. Okay, so there are different methods. So in third unit we are studying about moment distribution method only. Okay, so we are solve this problem by using moment distribution method. Okay, so whichever method is comfortable for you, you can adopt that method. Okay, yeah, but in this subject we are studying about the moment distribution. In an exam, if they mentioned about you solve the problem by using moment distribution method, means you have to use moment distribution. Okay, so I'm telling you in future. Okay, if you are working in a company or you are doing some engineering works, okay, so that time you can adopt, you can use any one method, whichever which you know. Okay, so this is a two span continuous beam AB BC. Okay, so the length of AB is 6 meter and length of BC is 5 meter. Okay, at a distance of 2 meter from point B we are having a point load of 40 kilonewton. Okay, so the first step is, okay, in a moment distribution method, first step is calculation of fixed end moment. Okay guys, okay, Raghunath, Raghunath, can you hear me? Mohana Priya? Okay.
Yes, sir.
Mohana Priya, what is the first step in slope deflection method?
Sir, find fixed end moment
Okay,
condition, sir.
calculation of fixed end moment. Similarly, in moment distribution method also, the first step is calculation of fixed end moment. Okay, so it is easy if you study both the methods by comparing. It will be easy for you guys. Okay. So first step, calculation of fixed end moments. Okay, so here we are having two spans. Okay, so fixed end moments will be 4. Okay, so each span has two fixed end moments. Okay, so totally two spans means four fixed end moments will come. Okay, first we have to take span A B. Okay, we have to consider both the supports. Okay, A and B as a fixed one. Okay, and we have to use the fixed end moment formula. So fixed end moment formula will is depends upon the loading condition. Okay, so here the load is UDL. Okay, so the fixed end moment formula is, what is fixed end moment formula? Amjatul, can you
W
answer?
square by 12, sir.
One second, one second.
So W
WL square by
Uh, WL square by
12, sir.
12. Okay, very good. So the fixed end moment formula is WL square by 12. If the load is UDL, okay, if the span is loaded with UDL load means, okay, the fixed end moment formula is WL square by 12. Okay, so left to right, okay, MFAB is will be anti-clockwise moment, and right to left, that is MFBA will be clockwise moment. Okay, so if the span has eccentric point load, okay, then what will be the fixed end moment formula? Morgan Kumar, can you answer?
so W A square W
Uh,
A B square by
Questions, sir?
L square, sir.
Sir,
okay,
questions.
WAB square by L square, that is left to right. Okay, anti-clockwise movement. What about clockwise movement? MFCB.
W B A square by L square, sir.
Yeah, correct. WA square B by L square or WBA square by L square. Okay. So first they calculate the fixed end moments. M of AB is equal to minus WL square by 12. So W is the UDL load, that is 30 kilonewton per meter. So length of the span AB is 6 meters. So 6 square by L 12. Okay. So we are getting the fixed end moment earlier as minus 90 kilonewton meter. So M of BA will be plus 90 kilonewton meter. Then MFBC is minus WAB square by L square. Okay. If the load is eccentric point load means fixed end moment formula is this. Okay. Anti-clockwise moment formula is minus WAB square by L square. So W value is 40 kilonewton. So 40 into A. A is 2. Okay. Here the A value is 2. B is 3. Okay. So AB square by, so 2 into 3 square by L square. The span length of BC is 5. So 5 square. So we are getting minus 28.8 kilonewton meter. Okay. Next, M of CB. Okay, that is right to left clockwise moment. So plus WA square B by L square. Okay, so this is the formula WA square B by L square. So 40 into A same 2 meter, B 3 only. Okay, so A 40 into 2 square by into 3 divided by 5 square. We are getting 19.2 kilonewton meter. Okay. Next step is, okay, first step is calculation of fixed end moment. Okay, so next step is distribution factor. Okay, so we have to calculate distribution factor. How much amount of moment will we have to distribute? Okay, so that is the for making that particular structure to an equilibrium condition, we have to do that work. Okay, so we cannot randomly distribute. We have to calculate the distribution factor. Okay, so by using that distribution factor only, we are distributing the moment. Okay, so second step is distribution factor. In distribution factor, in the second step itself, we are calculate the stiffness also. Okay, so like I already said, okay, so in the terms, technical terms we saw now first. So the first term is fixed end moment, second term is relative stiffness, third term is distribution, fourth term is carryover. Okay, so likewise only the problem also proceed. Okay, first we have calculated a fixed end moment. Second step, they are naming distribution factor, but after calculation of stiffness only, we'll calculate distribution factor. Okay, then after knowing distribution factor, we'll distribute the moment and we'll do carryover work also. Okay, so whether you are hearing me, Amjatul?
Sir, yes, sir.
Okay, guys. Okay. Okay. The step two is distribution factor. Okay. So we have to draw a table. Okay. So join. Okay, in the table we are having these terms. Okay, joint, member. Okay, then relative stiffness. First we are calculating relative stiffness. Okay, so this is a two span beam. Okay, we should not consider end joint. Okay, so A and C are the end joints. Intermediate joints only we have to take. Okay, so intermediate joint is B. Okay, they took intermediate joint B. And the members. Okay, members in that particular joint. Okay, so here we took joint B. So the members in joint B is, okay, so what are the members in joint B? BA is there and BC is also there. Okay, so in joint B we are having BA member and BC member. Okay, next stiffness. Okay, we are calculating the stiffness. Okay, so we know the stiffness formula. So what is that, Manisha? What is the stiffness formula?
3I by 4L, sir.
I think what about the next other formula? So 3I by 4L means for what support? For what
Hinged,
condition?
sir. For hinged, sir.
Far end is hinged means 3I by 4L. If far end is fixed means
4I will come, sir.
EA by L.
sorry
4 EA by L.
4EI by
L, sir.
L. If far end is fixed means 4EI by L. If far end is hinged means
3A by L, sir.
3EI by L.
L.
Okay, so I gave two formulas for both the supports. Okay, for each support I gave two formulas. Okay, if the far end is hinged means two formulas are there. Similarly, if far end is fixed means two formulas will be there. Okay, in book I show one formula. Okay, another one formula I gave orally. I asked you to write in the note whether you noted or not. I asked that formula. You tell that formula. If R and is fixed means what is the
I
formula?
by L, sir.
I by L.
I by L. Very okay. Very good. If R and is hinged means
3 I by L. 3E by 4L.
3 I by
I by 4L.
3I by 4L, sir.
3I by 4L. Okay. So these formulas are not in the book. Okay. But I gave orally. I asked you to write. Okay. By using this formula only, we are going to calculate. Okay. So we are not going to use that formula what they gave in the book. Okay, 4EI by L only if R and is fixed. If R and is hinged means 3EI by L. Okay, so this is also a formula. Okay, but we are not going to use. Okay, we don't know E value and all. Okay, we are not going to use E, that is Young's modulus value and all. Okay, if Young's modulus value is not known means we'll use the formula which I gave. Okay, if R and is fixed means I by L. If R and is hinged means 3I by 4L. Okay, so by using these formula only, we are going to solve. So relative stiffness. Okay. We took the joint B, and in joint B, we are having two members. Okay, member BA and members BC. Okay. So first we are seeing member BA. Okay. So now we are in joint B. Okay. Joint B, and we are seeing member BA. Okay. So far end is A. Okay, now we are in joint B. Okay, so the far end, and we are seeing member BA only. So the far end will be joint A. Okay, so what about the joint A? Whether it is a fixed support or injet support or roller support, which support? Guys, answer.
Hinged support, sir.
Injet support. Okay, if they gave a arrow mark means the support may be injet one or roller one. Okay, so this arrow mark indicates only vertical reaction in that particular support. Okay, so vertical reaction means maybe injet or roller only. Okay, depending upon the what type of load we are applying. Okay, so the reaction only act for that. Okay, so it may be injet support or roller support. Okay, so in member BA, the far end A is injet. Okay, so then what will be the formula? The stiffness formula.
I by L.
3i
I by
by
L
4l.
3I by 4. Okay, I by L is if far end is fixed only I by L. Okay, here the far end A is hinged. Okay, so the stiffness formula is 3I by 4L. Okay, 3I by 4L. Okay, by using this formula only, we are calculating. Okay, so 3I by 4L. Okay, the L is the length of span BA or AB. Okay, so what is that length? Length value is 6 meter. Span AB length is 6 meter. Okay, so 3I by 4L. So 3I by 4 into 6, 24. So 3I by 24. Okay, so this is the stiffness value for the member BA. Next, we will see member BC. Okay, in joint B, we have two members, BA, BC. Okay, first we calculated a stiffness for member BA. Next, we are calculating a stiffness for member BC. Okay, so member BC. Okay, now also we are in joint B only. Okay, so here now we are seeing member BC, and here the far end is C. So similarly, here also the far end is injured. Okay, it is also only having a arrow mark only. So it is maybe injured or roller. Okay, so the far end is injured. So the stiffness formula is 3I by 4L. Okay, so here L value is 5. Okay, BC span length is 5 meters, so the L is 5. So 3I divided by 4 into 5. Okay, so 3I by 20. Okay, guys. Okay, next summing. Okay, we are summing this relative stiffness. Okay, okay. So for the stiffness for joint B. Okay, in joint B, we are having member BA and BC. Okay, we calculate stiffness individually for the span. Okay, BA and for span BC. Okay, but we need to know the stiffness of joint B. So for that, we have to sum these both stiffness. Okay, stiffness of BA and BC. Okay, so stiffness of BA is 3I by 24, 3I by 24, and stiffness of BC is 3I by 20. So 3I by 24 plus 3I by 20. Okay, so we are adding these two values. Okay, and we are calculating the total. Okay, so 24, 20 means the LCM we are getting as 120. Okay, and we are simplifying. Okay, so and we are getting the final stiffness for joint B as 33I divided by 120. Okay, do you guys have doubt? If you have any doubt means you can ask. I'll tell once again. You guys note it down. You please note it down. Okay, just note down the formulas or this table. Anyway, I'm going to share the slide. Okay, so after summing the stiffness, okay, after adding the stiffness for that particular joint, the next step is distribution factor. Okay, so distribution factor is total stiffness. Okay, total stiffness divided by that particular member, stiffness of that particular member. So here the total stiffness for joint B is 33I by 120. Okay, so uh, so here the stiffness for member BA 3I by 24. So 3I divided by 24 divided by 33I by 120. Okay, relative stiffness divided by total stiffness. Okay, distribution factor. Please note it down. The formula for calculating distribution factor is relative stiffness divided by total stiffness. Okay, relative stiffness for a particular member divided by total stiffness. Okay, so relative stiffness for member BA is 3I by 24. Okay, so 3I by 24 divided by the whole thing divided by 33I divided by 120. Okay, so 3I by 24 into, we are cross multiplying. Okay, so denominator comes to the numerator. So 120 divided by 33I. So I and I'll cancel. Okay, so 333 11 times. So 120 divided by 24 5 times. So 5 divided by 11. Okay, so distribution factor for member BA is 5 divided by 11. Okay, so similarly for member BC also, okay, relative stiffness divided by total stiffness. So 3I divided by 20 divided by the whole thing divided by 33I divided by 120. Okay, so 3I by 20 divided by 33I by 120. Okay, after simplifying or cancelling this Okay, so we are getting the distribution factor for member BC is 6 divided by 11. Okay, so for member BA 5 divided by 11, for member BC 6 divided by 11. Do you guys have any doubt?
No, sir.
Okay, Santosh. So we can also cross check whether we are calculating this value, whether we calculated this value as a correct. Okay, we can do cross check. Okay, so how means, okay, for particular joint B, okay, in this problem, we are having only one joint, intermediate joint B. Okay, in that joint we are having two members BA and BC. Okay, we calculated relative stiffness and distribution factor. We calculated distribution factors. Okay, so we are getting two distribution factors for two members. For member BA 5 divided by 11, for member BC 6 divided by 11. Okay, if we add these two distribution factors means we will get 1. Okay, if we get 1 means then the calculations are all correct. Okay, so 5 divided by 11 plus 6 divided by 11. So what is the value? Manisha?
Sir, question one more time சொல்லுங்க sir. Yes, voice break ஆச்சு sir இடையில.
5 divided by 11 plus 6 divided by 11 is equal to
1, sir.
1 sir.
okay 1. Okay, so we can do the cross check. Okay, if we get 1 only, then the calculations are all correct. We have to get 1. Okay, we have to get the distribution factor 1 for that particular joint. Okay, whatever joint we are choosing means we have to get 1 only, then only calculations and all correct. Okay, this is a cross check. Okay, whether we are getting 1 and all, we have to do cross check some cases. Okay, in some cases, okay, if a particular joint has a 3 member, okay, so BA in this problem we are having 2 members, but in some cases we may have 3 members. Okay, then we have 3 distribution factors. Okay, if we have these 3 distribution factor value also means we have to get 1 only. Okay, then only the calculations and all correct. If we didn't get the value 1, okay, then we did mistakes somewhere. Okay, in the calculation of relative stiffness or maybe adding of the stiffness. Okay, so we have to rectify there itself. Okay, so in second step itself we can check it. Okay, if you didn't check it here, okay, then you go for a moment distribution, third step. Okay, there also you're getting the value. Okay, so your time will waste, energy will waste. Okay, so for that purpose only I ask you to check here itself. Okay, whether we are getting 1. Okay, so after calculation of distribution factor, okay, so that is step 2. Okay, in step 2 we are calculating stiffness and distribution factor. Okay, so after calculation of distribution factor, that is after step 2. So step 3 is moment distribution. Okay, so I want all you guys to take calculator, because you guys have to calculate and tell the values. Please take calculator. Please have a calculator with you. Don't use mobile calculator. If you have calculator means please take. Okay, then only it will be easy for you. And I also want you to take notes for this calculation of moment distribution table. If you didn't note how this value coming, how this these values and all, it will be, if you don't know means then it will be difficult for you. Okay, so please take calculator. I'll give 10 seconds time. Do you guys take the calculator or not? Ashok? Ashok? Whether you there or not? Okay, anyway, I'll start the problem. I don't want to wait. Okay, some other guys maybe listen now. Amjatul, Morgan, Manisha.
Yes, sir.
Okay, so then step 3 is moment distribution. Okay, step 3 is calculation of moment distribution. Okay, so in this also we have to uh, form a table. Okay, so first joint. Okay, first column may be joint. We don't need of a line and all. Okay, so okay, if you maybe you can use. Okay, otherwise you don't need of this column line. Okay, so first column is join. Then what are the joints which we have in that particular member? Okay, in this particular structure there are 3 joints. Okay, that is support only they are mentioning. So joint A, joint B, joint C, only 3 joints. Okay, so they put the 3 joints. So joint A, joint B, joint C. Next row. Okay, so after the join. Okay, so join, in that row we have to name that we have to name what are all the joints. We have to put what are all the joints there. Next row is the member. Okay, in that particular join. Okay, what are all the members? In join A we are having member AB. Okay, in join B we are having 2 members, BA, BC, and in join C we have 1 member, CB. Okay, you can see here in join A member AB. Okay, in join B member BA and BC, 2 members. Join A only 1 member, AB. Okay, in join B we are having 2 members, BA and BC. Next we are having join C. In join C we are having only 1 member, that is CB. Okay, you guys are clear? Sivakritiga,
Sir.
whether you have cleared it up to this step after
Yes,
join?
sir.
Okay, okay. So next step. Okay, I want all you please listen. Okay, so next step after join member. So next distribution factor. DF is nothing but distribution factor. Okay. So distribution factor only we calculated in the previous step only. Okay. So distribution factor. So distribution factor for join A. For join B. Okay. In join B, B member BA, BC. What are the distribution factor for BA, BC, and distribution factor for joint C, that is joint that for the member CB. Okay. Okay, so the distribution factor we calculated for a joint A or a member AB is nil. Okay, so we are putting a dash. Okay, and for member BA we calculated distribution factor as 5 divided by 11. Okay, for member BA we calculate the distribution factor value as 5 divided by 11. So 5 divided by 11. Similarly, for member BC, 6 divided by 11. So 6 divided by 11. Okay, for CB also no distribution factor, so we are putting a dash value. Okay. And the next step is fixed end moment. Okay, FEM is nothing but fixed end moments. The moment we calculated. Okay, so we have to put those values here. Okay, so first step, fixed end moment we calculated now. So we have to put these values there. Okay, MFAB, that is for member AB, we calculate the fixed end moment as minus 90, and for member BA is plus 90. Okay, so member AB minus 90, member BA plus 90. We have to use these symbols correct. Okay, positive or negative, we have to use these symbols correctly. Okay, then for member BC, the moment is minus 28.8, and for member CB plus 19.2. Okay, so member BC minus 28.8, member CB plus 19.2. Okay, so as of now, we are just substituting the values only what we calculated in previous steps. Okay, so join, member, distribution factor, and fixed in moment. Okay, we calculate distribution factor and we are putting those values. Similarly, fixed in moment also we calculate in the first steps and we are putting those values. Okay, so next only we are going for the calculation part. Okay, moment distribution doing. Next only we are doing the moment distribution part and carry over top. Okay, so What about joint A? Manisha, Manisha, can you hear me?
Yes, sir.
Hmm. So we substituted the values. Okay, we put the values what we calculated in the previous steps. Okay, that is distribution factor and fixed end moment. Okay, so first four rows and all easy. We have to remember first we have to put join. Okay, so we have to add joins. How many joins are there? Then member. Okay, what are all the members in that particular join? Okay, we have to put that. Then distribution factors what we calculated. Okay, we have to put those values. Then fixed end moment. So after fixed end moment, okay, I'll here itself. Okay, fixed end moments, now we are in third line. Okay, line number 3. Okay, so minus 90, these are the values we calculate in the first step. Okay, so join A, we are having a moment of minus 90. Okay, so what is a joint A? Whether it is a fixed support or a hinged support? Which support?
Injured, sir. Injured.
Hinged support. So hinged support means whether moment will be there.
No, sir.
No. So moment should not be at joint A, but we are having moment. Okay, moment of minus 90. So we have to remove this moment. Okay. Similarly, so join B. What about join B? Join B is hinged support or roller support? What support?
Intermediate support, sir.
Whatever support may be. Okay, whether it may be injured or roller, but it is intermediate, so we have to consider that one as a fixed support. Okay, so the moment will be there. So we are having a moment of plus 90 in joint BA, that is member BA. Similarly in member BC you are having a moment of 20 minus 28.8. Okay, so we don't have any issues in these portions. Okay, so at joint C, what about joint C, whether it is fixed or injured?
Injured, sir.
Injured. Okay, similarly, here also we should not have moment, but we are having moment of 19.2 kilonewton meter. Okay, so here also we have to remove this moment. Okay, so the next step is release A and C. Okay, release the moment at A, okay, and at C, and do the carryover. Okay, how can we release the moment? We are not release means we have to make zero moment at point A. Okay, that only we are doing. How to make zero moment means we are having an addition minus 90 kilonewton meter anti-clockwise moment. So we are applying a clockwise moment of plus 90. So it will be nullified. Whether you guys are understanding how I'm making that particular joint to a zero moment. Okay, it is having a minus 90 means anti-clockwise moment is there. So I'm applying a clockwise moment of 90 kilonewton meter. So the moment at joint A will become nullified. Manisha, whether you're understanding or not.
Yes, sir.
Okay. So similarly, at joint C also, we are having a clockwise moment of 19.2 kilonewton meter. So what we are doing here? Manisha,
Sir.
what we are doing here? We are having a clockwise moment of,
Carryover.
we are applying an anti-clockwise moment. Okay, guys. So we are adding moment. Okay, we are additionally adding the moment here. Okay, to make that particular joint as a nullify moment to a nullify moment. Okay, so we are additionally adding the moment here in joint A. We are applying a clockwise moment of 90 kilonewton meter, and at joint C we are applying an anti-clockwise moment of 19.2 kilonewton meter to make the joint A and joint C as a nullify in moment wise. Okay, so if we add additional moment means, if we are adding a moment means, okay, what is the name of that particular moment? Technically, we have called that moment as a
Distribution.
carryover moment. Okay, so we are in this we are adding a moment of clockwise moment. Okay, in joint A we are adding a moment of 90 kilonewton meter. Okay, so if we add a moment of a moment means half of the moment will go to the near end. Okay, that is far end. If the far end is fixed, means the moment will transfer. Half of the moment will transfer. So half of 90 means what is the value? There is reply. So half of the moment means 90 divided by 2. Half 90, half of 90, 45. Okay.
45, sir.
Okay. So now in joint B, in joint A, we are in member AB. That is in joint A only we are here. Okay. The far end is B. So B is intermediate support. So all intermediate supports are considered as a fixed. So fixed means moment will go. Okay. So 90 divided by 2, 45. Okay. So an additional of sorry clockwise moment. Okay, we are applying clockwise moment only now. So half of the clockwise moment will go to the member B, that is joint B. Okay, so plus 45. 90 divided by 2 is plus 45. So plus 45 will transfer to the member BA. Okay, so we are applying in AB only now. We are applying an additional moment of 90 kilonewton clockwise moment. Okay, we are applying a clockwise moment of 90 kilonewton meter. So it will half of the moment will carry over to the joint B, that is member BA. Okay, clockwise moment. So 45, 90 divided by 2, 45 plus 45 kilonewton meter. Okay. Similarly, in joint C also we applied a moment of anti-clockwise moment of 19.2. Okay. So here also half of the moment will transfer to the joint B, that is member BC. Okay, 19 divided by 19.2 divided by 2 is 9.6 minus 9.6. Okay. So minus 9.6. Okay, guys, whether you're understanding up to this step, up to the line 4. Amjatul,
Sir?
whether you understood or not.
Yes, sir.
Okay, so after line 4, that is after releasing A and C, and we do carryover also. Okay, we did two process in this line 4. Okay, first we release the moments at joint A and C, and we did carryover also. C bar is nothing but carryover. Okay, the 45, the moment 45 is only we termed as a carryover moment. Not the additional moment is a carryover moment. Okay, the moment transferred carryover is 45 only. So 45 is the carryover moment. Here minus 9.6. Okay, that is carryover moment. So after this step, the next step is initial moment. Initial moment means we are adding the value. Okay, from fixed end moments we are adding. Okay, so fixed end moments minus 90 at joint A. Okay, in line 3. In line 4 we are adding an additional 90 plus 90. So we are adding these two values. So what? 0 minus 90 plus 90 is 0, plus 90 plus 45 plus 135 minus 28.8 plus minus 9.6. Okay, we are adding these two, so both are minus. No, so we are getting minus 38.4, and plus 19.2 minus 19.2 is 0. Okay, so now join A and join C become nullified in moment. Okay, there is no moment at join A and join C. Okay, only we are having moment at join B. Okay, join B, that is member BA and BC moment values in those joints. Okay, since join B has two members, then we'll have two moments. Okay, 135 and minus 38.4. Okay, Sivakritika, are you there? No. Okay, so Mohana Priya.
Sir,
So what is the third step in slope deflection method?
sir, equilibrium equation find பண்ணுங்க.
Joint equilibrium equation. Okay, can you say joint equilibrium equations for this particular member?
MBA MBA plus MBC is equal to 0, sir.
Very good, correct. Okay, since joint B has two members, it has two moments. Okay, one is MBA, another one is MBC. If we add these two moments, okay, MBA plus MBC, then we have to get 0. then only this particular joint B will be balanced one or stable one or in equilibrium. Okay, so that only we are naming that particular step as a joint equilibrium equation or joint equilibrium condition. Okay, so we have to get, okay, MBA plus MBC is equal to 0. Okay, here we are getting MBA as 135. Here MBC, moment at BC. Okay, these are moment only, initial moment value only. Moment at BA is 135. Moment at BC is minus 38.4. Okay, so whether this particular joint B will be in equilibrium? No. Okay, if we add these two means we have to get 0. But here will not get 0. Okay, so we have to do balancing portion. Okay, that is distribution. Okay, we have to distribute or balancing. Okay, so I want you to please write down this. I want all of you to please write down this particular steps from at least from fifth step. Draw this particular table and note down from fifth step. Okay, it is not given in the in this book. Okay, please note it down. Please note down this tabular column. Okay, draw the first line, joint A, B, C. Okay, you can also leave this first to four step. You can write from fifth step. Okay, fifth step only. From fifth step only, I'm going to tell how they are did this 43.9 and all 52.7 and all how this value come. Okay, we are distributing the modes. Whether you note it or not. Okay, Manisha.
Sir,
So MBA plus MBC is equal to 0. Okay, we have to get 0. But what value we are getting here? 135 plus minus 38.4. What is the value?
One nine.
240, sir.
Manisha,
Sir, 1 minute, sir.
Mona Priya,
Calculate fair model இருக்கு, sir.
Mona Priya, you can answer.
Sir, 135 minus 38.4 தானே sir?
Minus 38.4.
96.6 sir.
Okay, 96 point. Manisha, you please mute.
Sir,
Mona Priya, you tell the answer.
96.6 sir.
96.6. 135
Minus
plus
38.
minus 38.4. We are getting
96.6.
we are getting plus 96.6. Okay, please all of you note down this value, plus 96.6. Okay, plus 96.6. Okay, so that is the difference between these two, between member BA and BC. The difference is 96.2. Is it correct, Mogna Priya?
96.6 sir.
96.6. Okay, so 96.6 is the difference between the moment at BA and moment at BC. Okay, so now we have to distribute that 96.6 only. Okay, so how we are distributing means by using the distribution factor. Okay, so for that only we have calculated the distribution factor. So for member BA, we have to distribute this by using this factor, 5 divided by 11. And for member BC, we have to distribute by using 6 divided by 11. Okay, so the difference is plus 96.6. So we have to apply minus value. Okay, plus 96 means clockwise only move. So we have to apply anti-clockwise. Okay, we are applying the moment. Okay, like that, or distributing the moment. Okay, so minus 96.6. Okay, we are applying the moment only. So plus 96.6 is the difference. So we have to apply minus 96.6. Whether you are understanding or not. I'll tell once again. Okay, so the moment at BA is plus 135 and moment at BC is minus 38.4. If we add these two moments, we have to get zero. Okay, then only that particular joint will be in equilibrium position. Okay, but in this case, we didn't get zero. Okay, plus 135 minus 38.4. If we add these two value means we are getting plus 96.6. Okay, the clockwise moment only more. Okay, so we have to apply minus 96.6. Okay, where we have to apply minus 96.6? How we have to apply that minus 96.6? Okay, that is the question. Okay, we have to apply anti-clockwise. So that only we calculate a distributed factor. Okay, so we have to use that distribution factor. Okay, so we have to apply the difference is plus, so we have to apply minus value. Okay, so minus 96.6 into 5 divided by 11. Okay, so what is the value? Please tell. Momna Priya. Momna Priya.
Sir, 43.9.
Okay, so 43 points. So we have, if the difference is positive, isn't plus means we have to apply minus value. Okay, so for member BA, distribution factor is 5 divided by 11. Okay, we are getting plus difference plus 96.6. So we have to apply minus value. Okay, so minus 96.6 into 5 divided by 11, we are getting minus 43.9. Okay, so in balance, next step is balance. Okay, we are making that particular joint as a balancing. Okay, now the joint B is not a balanced one, so we are making the balancing for joint B. Balance B is nothing but balancing joint B. Okay, so in member BA, we are applying a moment of minus 43.9. Okay, all clear how this value came. Vignesh, Santosh,
Yes, sir. Yes, sir.
the value எப்படி வந்தது புரிஞ்சுதா? Minus 43.9.
Yes, sir.
Okay, okay, guys. Okay, similarly, in this joint BC also. Okay, so difference is plus, so we have to apply. Okay, so minus 96.6 into 6 divided by 11. Minus 96.6 into 6 divided by 11. What is the value?
Minus 52.7, sir.
Calculator ஒர்க் பண்ணி பாரு. சும்மா இங்க பார்த்து ஆன்சர் சொல்லிட்டு இருக்காத. நீ calculator ஒர்க் அவுட் பண்ணி பாரு.
Calculator work
Okay.
பண்ணிட்டு.
Okay, okay. So minus 96.6 into 6 divided by 11, we are getting minus 52.7. Okay, so we are additionally applying the moment. Okay, at joint BA and joint BC. Okay, we are applying an anti-clockwise moment at joint BA for making the joints B as a balanced one. Similarly, we are applying a moment of anti-clockwise moment of 52.7 in member BC. In member BC. Okay, that is anti-clockwise means BC only. Okay, no, to make the joint B as a balanced one. Okay, if we apply a moment additionally means what we have to do? We have to do carryover. Okay, if far end is fixed means we have to do carryover. Okay, but in this case now we are applying moment at BA. Okay, so BA means here only we are applying a moment. Okay, so what will be the far end? Manisha? No, Manisha is not here. So okay, the far end is A. Okay, so what about joint A? Joint A is injured one. Okay, if it is fixed means the moment will carry over here, but injured means the moment will not carry over here. Okay, so the next step after balancing we have to do carryover, but in our problem, in this problem, okay, we are having injured end only. Okay, the far end is injured. Joint A is injured, joint C is also injured, so we didn't do the carryover. Okay, half of the moment will carry over. Half of the moment is 43.9 divided by 2. Okay, the moment will carry over here to the joint A. Similarly, 52.7 divided by 2, the moment will carry over here. Okay, but we didn't do the carryover steps in this problem. Why means because the far end is injured. Okay, for member BA the far end is A. Okay, the end is injured. Similarly for member BC Okay, the far end is C, the NC is injured. Okay, so we didn't do the carryover. Okay, so final moments. The last step is calculation is final moments. Final moment is nothing but we have to add. Okay, from initial moment we have to add. So 135 plus minus 43.9 will get plus 91.1. Similarly, minus 38.4 minus 52.7. If we add these two means we'll get minus 91.1. Okay, so we can check here MBA plus MBC is equal to 0. So MBA value plus 91.1, MBC value minus 91.1. So if we add these two moments, we are getting 0. So the joint B is balanced. Okay, guys, whether you understood or not. Santosh?
Yes, sir.
Okay, okay. Okay, I'll stop here. We'll see in the next class. If you have any doubt, you can ask me, you can call me. Okay, I'll share this PDF to your group now. Okay, thank you, guys.
Yes, sir. Thank you, sir.